We typically see quadratic functions written in standard form. In fact, if we see a quadratic function that isn't written in standard form, our first instinct is to rewrite it in standard form to make it easier to factor. Remember, a quadratic function is written in standard form when f of x equals ax squared plus bx plus c. We know that the sign of a tells us the direction the parabola opens, and that the y-intercept of the parabola is 0c. There are some pieces of information about quadratic functions that are easier to see when the function is written in a different form. If we write the quadratic function as f of x equals a times the quantity x minus h squared plus h, a still tells us the direction the parabola opens in, but now we have h and k instead of b and c. What do h and k tell us? The coordinates of the vertex of the function. A quadratic function written in this form is said to be in vertex form. The coordinates of the vertex are h, k. Now let's look at an example. We want to find the vertex of the function f of x equals 3x squared plus 24x plus 41. In this case, we'll find the vertex by rewriting the function in vertex form. One way to rewrite a quadratic function in vertex form is called completing the square. We begin by factoring 3 out of the first two terms of the function. Next, we want to rewrite x squared plus 8x as a perfect square trinomial. We can do this by adding a specific value to x squared plus 8x, which completes the square. The value we need is equal to the quantity b over 2 squared. b is equal to 8, so we have the quantity 8 over 2 squared, which is equal to 16. We have what we need to complete the square, but we can't just add something to one side of an equation. In order to maintain equality, we add and subtract 16 inside the parentheses. Now, factoring x squared plus 8x plus 16 gives 3 times the quantity x plus 4 quantity squared minus 16 plus 41. Distribute the 3 and then combine like terms to find f of x is equal to 3 times the quantity x plus 4 squared minus 7. Now, the reason we rewrote the function in this form was to find the vertex, which is at hk. But if we look at our function written in vertex form and the general vertex form, you'll notice that our signs are different. This places our vertex at -4, -7.